Alright, let's look at the homework 12.5, problem number 4. Alright, so we want to find an equation of the plane passes through the point 2, 4, 5, and it contains the given line. Alright, so let's do that. Alright, so we have a plane. Alright, and we have a point on that. So we have a point is given. So that is 2, 4, 5. All right, then you have contains a line. So you're going to have a straight line sitting on there like that. All right. So we know that from the equation, we can find a point on the line, which is going to be on the plane too. So here's the point, right? So we can say, so there's no constant here, so x component is 0, and the y component is 2, right? And the z component is 4, right? Then we have a direction vector, so this is going to be along that line, so the direction vector. So I'm going to call it, say, v or something like that, right? So this is going to be x component is 5, just to look at the coefficient of t, and 1 for the y component, and a -1 for the z component. All right, then we want to find a vector perpendicular to the plane. So we're looking for this vector here. So like this is a normal vector n, and we know that this is going to be perpendicular to the line, of course. And also, if you think of a vector here, it's going to be perpendicular to that guy too, right? So we can find the normal vector by simply taking the cross product between these two vectors, right? So we have to find the other vector too. So the other vector is going to be, I'm going to call this vector, say, vector w or something like that, right? We can just do 2 minus 0 is 2, 4 minus 2 is 2, and 5 minus 4 is 1, right? So we can just take the cross product between these two. So I'm going to just take the cross product between, say, vector v and vector w. That's going to be our normal vector. All right, so let's go ahead and do that. All right, so here's I, vector j, vector k. All right, and the v has a component of 5, 1, -1, and w has a component of 2, 2, 1. All right, so first component is going to be 1 minus -2, so it's plus 2, minus, all right, 5 times 1 is 5, minus -1 times 2 is a negative, so it's a plus 2. All right, last one is 10 minus 2. All right, so you can see that this vector is going to be 3, -7, 8. All right, so we found a normal vector, and we can use any of the points given. So why not just use 2, 4, 5? So the plane equation of the plane we're looking for would be 3 times x minus 2 plus actually minus 7 times y minus 4 plus 8 times z minus 5, and this is equal to 0. All right, so let's type it in. All right, so the equation we found was 3 times x minus 2 minus 7 times y minus 4, and let's see, last one was plus 8 times z minus 5, and that's equal to 0. All right, so let's check the answer. All right, submit for testing, and all right, it came back and looks like we got this one correctly. All right, That's it. I hope that this was clear.